system of 2 point charges. Potential energy of system of 2 point charges. Now you can this. It was but અત્યારે કર્યું તો વાંધો નહીં નહીતર તમારા કાંડ આવી જશે બધા આમાં રેકોર્ડ થઈ જશે કે ક્યારે કોને ફોર્મ્યુલા નથી આવ્યું બરાબર ને Sure. So suppose that there is a positive charge, let's say Q1, small, okay, and here is another charge Q2. Let's say both are positive. Negative in the paper, derivate this way. Suppose the distance between them is R. You can also write R12, distance of 1 from 2. Okay. Now we have to find its potential. There are two ways to do it. Method 1. We do it by integration first of all. Do you remember the general formula for potential energy of a system? Negative integration F vector dot dr vector. When you bring some charge from infinity to that point P, let's say this point is P, and suppose this is fixed. Okay. So if we do the integration and all that, Fe vector, force between these two would be k q1 q2 by r square when the distance is r. Okay, that r may not be this. It's like we are thinking that suppose we bring this all the way from infinity to this point. Did you get it? Suppose we bring this all the way from infinity to this point. So that is k q1 q2 by r square r hat, Coulomb's law in vector form. Fine, everyone get that? Yes. Sure? Yes. Dot dr vector. Dr vector we can always write as dr r hat. Clear or not? Okay, r hat dot r hat is what? Constants to be kicked out. Therefore, u is equal to minus outside, k outside, q1 outside, q2 outside. Okay? We will just have integration of r raised to minus 2 dr. Now I will change the limit value, that is everything now is in form of distance. So when it is at infinite, the distance is also infinite, obviously. This point is very, very far. This is at infinite. So distance of that point from this charge should also be infinite. Is that okay? Now when that thing comes to P, the final, here, what's the distance between them? R. Clear or not? Sure? I hope changing the limits is not a trouble for anyone. I'm asking you this because some people in the other class asked me, how did P become R? Because P is representative of the final point and this is representative of the final distance, because now you see this limit, I mean the integration is not anymore in the form of initial to final, it's just about dr means distances. The final distance R, initial distance infinite. Okay. So, minus k q1 q2. What's the integration of r raised to minus 2 dr? R raised to minus 1 by minus 1. Is that okay? So, divide by minus 1. R raised to minus 1. Put it in box like this. Correct? Yes. Clear or not? Yes. Okay? Integration formula. I hope everyone remembers that integration formula. Alright? Okay. So, minus plus k q1 q2. Okay, now here. First of all, r raised to minus 1 means 1 by r and then minus 1 by infinity. It's okay if you don't write this. We know that 1 by infinity will become 0. So finally this will be k q1 q2 by r. So that's the formula of what? Potential energy. System is no charge. Potential energy of 2 point charges. Method 1 clear. This is the method which I think is given in the book. Okay? Okay or not? Everyone got this completely? Yes. Right. Method 2 is a frank one. Okay. You know that U is equal to QE, yes or no? Yes. Yes or no? Yes. So suppose we think that this charge is creating field and potential and everything, then if you are putting this charge Q2 in the field of the first charge, then it should be like this, yes or no? And repeat what I have said. We say that U is equal to QB. What does this mean? It means that if you put a charge Q at some point where the potential is V, then the potential energy is U equal to Q into V. V is potential, U is potential energy. So I'm saying that we are putting the charge Q1. Okay, where are we putting it? We are putting it at, we are putting the charge Q2, and where are we putting it? At P. Is this clear? Yes or no? And the potential at P is created by which charge? By the first charge, not by itself. A charge cannot affect itself, remember. Otherwise, we would move on our own. Okay, we could also fly. We are not kidding. If you just make one sentence that a charge can apply force on itself, then we can fly on our own. Okay? Alright, world would be a very interesting place. Well, anyway, so here, Q2. Now, do you remember what's the formula of potential at a point due to a point charge? Yes. What? KQ by R. So what should I write here? KQ2 by R. Yes or no? Yes or no? Potential due to first charge. Yes or no? So when you write KQ by R, that Q is which charge? The charge that creates the potential. Yes or no? If I would have done it straight away, so clear or not clear? Can't you do it like this? Can't you say, can't you say that first one is put in the potential of the second one? Got અરે એવું નહીં તો એવું પણ કીધું અને કીધું ના કીધું તો અને ઓલાને મૂવ કરીને લઈ આવો gives the same answer of course. Is that okay or not okay? Right, so there is no partiality, remember, there is no partiality. Even if you do it this way, you get the same value of potential energy. Basically this is a lesson that u of 1 with 2 or u of 2 with 1 is always same. U of 1 with 2, u of 2 with 1, they're always same. Clear? Sure? Oh, fine. Yeah, there is a formula. What is R in this? Distance between the 2 point charges. Again, do not use it for anything except 2 point charges. Alright? Everything will be example. Okay. Next, silly problem. Potential energy of system of multiple charges. નાના છોકરાઓનો ટોપિક કેવો? Potential energy of system of multiple charges. So suppose you have got a system where let's say there are 3 charges. They may be positive, may be negative, but they are point charges. Okay, actually point. So how to make potential energy? You just have to take everything pairwise. Okay? Pairwise, that is, make pairs. 1 with 2, 1 with 3, 2 with 3. All that is due to superposition principle. So this is what we have. So now let's start it. Any average? Potential energy of a system of multiple point charges is found by taking mutual potential energies pairwise. Is found by the sum of mutual potential energies pairwise for all the charges. Clear? So if there are 3 charges, we have 3 pairs. I hope you realize that in general we have NC2 pairs, that is n into n minus 1 by 2. Clear? Clear or not clear? Yes. Okay. Right. So if there are 4, you'll have 6 pairs. So like that you can cancel. You can simplify this a little bit. Okay, તમને બહુ એવું લાગે કે ના ના હજી કંઈક લખી લે તો લખવાનું. What does all this mean? R12 means distance between 1 and 2. R13 means distance between 1 and 3. Like that. Is it clear? Okay. Fine. Easy, ne? अब gravitation में आओ. Okay. Right, now we are ready to solve a few questions. First of all, let's see if there are some worthy examples. We have done 2.2. Right, let's do 2.4, then we'll come back to 2.3. 2.4, example 2.4. 4 charges are arranged at corners of a square, ABCD of side D as shown in figure. How question gravitation may put them. Find the work done. See, there are only 4 charges. Don't be fooled by diagram. They are giving only one diagram to cut cost. Okay? What is given? There are 4 charges arranged at the corners of a square. Got it, everyone? Right. So draw the diagram. Come on. 4 charges as shown. All are not same. Some are Q, some are minus Q. But do not draw the charge at the center. Please, I hope you found the question now. Stop flipping the pages. Okay. So here's the square. A, B, C, D. What's the charge at A?
Plus Q.
Plus Q. Okay. What's the charge at D?
Minus Q.
At C?
Plus Q.
At D?
Minus Q.
We have to find. What do we have to find? A. What do we have to find? Work done. Work done to put together the arrangement. Means we have to make this. Okay, so before we make this, there was nothing. Is that clear? Nothing. That is, all the charges were far away from each other at infinity. Is that clear? Okay. So, how much work do we need to do to make this? That's the question. How much work we need to do? We, that is external. So, we have to find W external required to make this system. And again, you don't need to make the system fast. Assume that human lifespan is infinite, so make it very slow. Understood? Take all the time. Okay, universe isn't going anywhere. So, UF minus UI will give us that. See, all this is only because we are making it slowly. Otherwise, this is wrong. Do you remember the steps in between these two? First of all, W external is minus WE. If you are doing it slowly, okay, and minus WE will always be equal to delta U. Delta U is UF minus UI. So ultimately, W external is UF minus UI. But our formula નથી ગમે તે યાદ ન કરીને યુઝ ન કરવાની જ્યાં હોય અહીંયા. Is that clear? It is only valid if you are moving charges slowly. કોઈ વાર એવો ક્વેશ્ચન આવશે જેમાં ચાર્જ સ્લો નહીં મૂવ થતો. Never mind. Here. So UF minus UI. Final potential energy we can find because we are given the distance. I believe what's the side of the square? D. D is the side of the square. Alright. What will be initial? Initially all the charges were at infinite. That's what I said. We want to make the system. So initially you can consider all the charges were very, very far from each other. At infinite distance the potential energy will be 0. Very good. Okay. So UI is equal to 0. Fine. Now we have to find UF. Okay. Go on it again. So this is equal to. You have to take all the pairs. How many pairs will be there? 6 pairs. Is that clear or not clear?
Yes.
Okay. Start. UAB, UAC, UAD plus UBC plus UBD plus UCD. Do you understand?
Yes.
Yes or no?
Yes.
Sure. Okay. एक के बेट हम कर लो बाकी बची छोड़ दे. Okay. Who can tell me what is UAB? Raise your hand. UAB. અહીંયા charge. Distance between them D. Use the formula. Potential energy of 2 point charges. UAB. Come on people. આવડે એવું જ છે આમાં કઈ નો આવડે એવું છે જ નહીં. સવાલ જ નથી.
Q square by D square.
K
Q square.
Q square. અહીંયા KQ minus Q upon D. Is that clear or not clear?
Yes.
K Q minus Q upon D. Yes or no?
Yes.
Formulas are there.
K
Q1 Q2 by R. Okay, Q1 Q2 minus Q. Distance. Take your name. Okay. Now raise your hand for UAC. Who can tell me what is UAC? Who can tell me what is UAC? Okay. તેનો મતલબ પહેલા નહોતું સમજાણું હવે થોડુંક આવ્યું અને આવું જ કરવાનું છે મકાઈ નથી કરવાનું. ઓકે વેરી ગુડ યસ શ્રીમા. A Q upon D. Sure? Absolutely sure? Nice. What's the distance between A and C?
D.
Happy mistake nahi karo. Okay. Sit down. Is this clear?
Yes.
The diagonal is root 2D. So that's why we have to write root 2D. Like this, can you write down all the terms?
Yes.
And simplify it on your own. Alright? Okay. There's some more question over there. It's a deeper. Alright, what is the part? Let me read it. It says a charge Q0 is brought to the center of the square, 4 charges being held fixed at the corners. How much extra work is needed to do this? Right. So first of all, it's important to understand the question. Here, what does it say? The square is already there. The square is already there. Now we have to bring one more thing. Clear or not?
Yes.
What's that charge? Q0. And where do we have to put it?
Center.
At center. Alright, so this is the initial diagram. Now for part B, do you realize that this diagram becomes initial diagram? Yes or no? Because all the charges are already there. And what would be the final diagram for part B? What do you think? Finally, શું કરવાનું છે એમને જ રાખવાનું કે કઈ ચેન્જ કરવાનું. Okay, so at the center we'll have Q0. Is that okay?
Yes.
Sure. This point starts here. Find at E. This is final then. Read the question. What do we have to find? How much extra work? Extra means whatever we did here, W external we found it. Fine, that's it. Now, how much more? How much extra? Is that clear? Do we have to do to go from this situation to this situation? Okay, this initial to final. Make sense? Clear? So what we learned next? W external should be equal to, if you do it slowly, again if you want to bring this charge Q0 slowly, W external will be equal to minus WE, and that would mean it is equal to delta U. That means once again it is equal to UF minus UI. Okay or not okay?
Yes.
Alright. Now, we already have UI if you think about it that.
Yes.
UI થઈ ગયું પહેલા UF હતું હવે UI. Is that clear?
Yes.
You just have to find UF and put it here. But there's a smarter way. You see, this is delta U. Delta U, that is change of potential energy. So we should only worry about that thing which will change. Are these charges moving at all? 4 charges, are they moving? No, they are fixed. So do you realize that the potential energy of A with B cannot change? Because potential energy is depending on distance. Do you understand that potential energy of A with B will not change? Yes or no?
Yes.
So when you are talking about delta U ultimately, the external is delta U. You are talking about delta U. So one term, UAB, will never change. Will UBC change? This one? Only those terms will be added or extra, the ones that are involving Q0. Who understood that? The terms involving A, B, C and D only will not change at all. Clear or not? So they change nothing those when you come delta mark and use karani જરૂર. Make sense?
Yes.
Sure?
Yes.
Okay, you know it's like if you have got 2 pockets. In one pocket you have 100 rupees, in the other one you have 50. You give something from this pocket. Okay, and alright, you change the amount. Let's say from 50 it becomes 70. Give or take, whatever. તો પછી આમાં કઈ જોવાની જરૂર છે? You understand what I'm saying? Okay. The constant part we are not going to change, right? We are not worrying about it at all. Okay, so delta U will be equal to U of A with E, U of A, E with B with E, U of C with E, and U of D with E. Where is everything else? Cancel. It will get cancelled. You know, if you don't like my method, no worries. Consider this as initial. You have already found it. Happy जो diagram. Finals out से बस ऊपर एक कर ले जो बस ऊपर ले जो. You'll get this. Clear or not clear? Yes. कारण कि पहला 100 था, પછી આખી જમ 100 જ હતા. तो subtract करते ત્યારે 100 कट पे जाए ना obviously. Is that okay? Yes. So this is what we get. Fine. Right. How much is this? First of all, UEA. Correct. How much is UEA? E with A. A. U0. Upon. Distance. How much distance? D by root 2. Divided by root 2.
Root 2 by D by 2.
From here to here is half of the diagonal. Okay, that's the reason. D by 2. Okay, now B with E.
Minus.
Same as I was saying, but with a minus sign. Yes or no?
Yes.
Sure. Okay, so these two terms will get cancelled. What about C and D? Answered?
Yes.
Sure?
Yes.
Okay, you guys are getting smart. So this is true. Understood?
Yes.
Fine?
Yes.
Now you can start reading the previous example. We might be going, in random order according to book, but trust me, we are following a better order compared to what is given in the book. Okay, the previous example is about some field lines and all that. Okay, that one. Right, let's begin. It's basically a conceptual method which will give us an important result. So, what's given here? Let's see. So, the figure shows field lines of a positive point charge and a negative point charge respectively. You don't need to look at both together. Alright, you don't need to look at both of them together, right? They're separate figures. Give the sign of potential difference Vp minus Vq and Vp minus V. We don't need to do both together. We'll only do question of figure A first, then we'll solve all questions of figure B. So first of all, just look at figure A. So what do we have? A positive charge here, and field lines are coming out from a positive charge as we might expect. Clear or not? Okay. Now there are some 2 points given. Yes or no?
Yes.
Where are they given? Somewhere here?
Yes.
P and P.
P.
Then there is
Q.
Q like this.
Yes.
Okay, it might be a little bit to the side also, that doesn't matter. But suppose, roughly speaking, you can say that you might draw a field line and it's possible that one field line goes from P and Q. What if this is a little bit on the side? No worries at all. Okay? But if you put it like this, it will be easier to understand. Okay? Because P and Q are not like an exact location. They are just randomly given somewhere up there. Right? So let's start. So it says that give the sign of potential difference. Which potential difference? Vp minus Vq. Sign means positive or negative or zero. That's what we have to do. It depends on which is more and which is less. Yes or no?
Yes.
Yes or no?
Yes.
Sure?
Yes.
Right. Look at this positive charge. Look at these 2 points. Which one is closer to the point charge?
Point
B
B.
is closer?
Yes.
Sure?
Yes.
Which point is closer? Will the potential be more or be less?
More.
Are you sure?
More.
Or are you guessing?
More.
How? How can you say free?
Inversely proportional.
V is inversely proportional to R. Is that clear or not clear? Potential due to a point charge kq by okay. So if R is more, potential is less. If R is less, potential is more. Is it fine? So clearly, which is more, Vp or Vq? Vp is more. That's why this will be positive, greater than 0. Clear or not? Okay. That also points out something very nice. Do you realize the electric field lines, they are pointing from P to Q? Okay, they are going from P to Q. Is it fine? Similarly, if I take 2 points here, C and D suppose, then C will be at high potential, D will be at low potential. So again, electric field lines are pointing from C to D. That is, they are always pointing from higher potential to lower potential. This is true. Okay. In every case is going to be true. I'll of course prove it a little bit later as well, but even intuitively, just by looking at this diagram, it should click to you. Okay, it's a very useful result. Right? Okay, always, not for this question. Right? Electric field lines always point from higher potential to lower potential. This sentence can also be written in another way. It that as we move in direction of electric field or electric field lines. See, direction of electric field and direction of electric field lines is always the same. I hope no one has confusion about it. Whether you write direction of electric field or you write direction of electric field line, the meaning is always same. So as we move in direction of electric field or in direction of electric field line, the potential will decrease. Potential will decrease. Both sentences are telling you the same thing if you read it carefully. If you move like this, potential will decrease. Clear or not? Sure? Yes. Right? These are very, very useful. They will avoid you, they will help you to avoid silly mistakes, right? They can be very useful when you get confused. Okay, erasing there. चलो मान लो B part करते हैं. Yes. B part. What about B? Not figure B. Question B. Give the sign of potential energy difference of a small negative charge. Between Q and P. Even though they are writing Q and P, but I know that they are asking P and P. That is UP minus Q. Okay. Right? Now basically what I am doing is, here we are asked VP minus VQ, so there also we are writing UP minus. But the difference पूछे तो आम में होए सके नाम में होए सके ठीक है. All right. So don't worry about it. Yeah, we are going to find UP minus. Now, is there a way to relate this with this? Yes. What's the problem? Delta U is equal to Q delta V, or U equal to Q into V. Understood or not, everybody?
Yes.
Very simple relation used here. Okay. Now here we are given that a small negative charge moves from what? P to Q. Okay, Q to P. Never mind, there is a small negative charge. It is moving somewhere between these two. Fine. Okay or not okay? Whether it moves this way or that way, this answer does not change. Right? Because this has nothing to do with how it moves. It just has to do with points. Right? So this charge Q that is moving here is the potential or electric field of this charge. So here this charge is negative. Correct? Yes or no? Yes. Sure. Absolutely. Yes. Q sign negative. This bracket, that bracket. Sure. Positive or negative? Positive. Positive. So negative into positive. Negative. Is it clear? So that means UP minus UQ is less than or negative. Understood?
Yes.
Q is negative. Is that clear? No. No. Not clear. Clear or not clear? Read the question. Clear. Small negative charge Q would be moving between these two. So that would mean this Q is negative and this bracket is positive. So multiplication would give negative. Clear? Fine, everyone. You know there is another way to do it, but I think nothing can beat this method. The other way is if you look at the potential energy of 2-point charges, one positive, one negative. One positive and one negative. So it would be something like some negative number divided by R. Yes or no? Something of this kind. Then this is negative. Yes or no? Numerator is negative. So you know the trend gets reversed. આ તો સમજાણો છે કે આ તો સમજાણો કેમ છે ફોર્મ્યુલા શું ફોર્મ્યુલા q = aq1 by r હમણાં ડિરાઈવ કર્યું ઓકે or not okay sure. So because of this minus sign the trends are reversed. That is if the minus sign wouldn't be there, I'm sure all of you would understand that if r increases u will decrease. Yes or no? If minus sign was not there. Yes, no. Yes or no? Yes. Proportionality. But if there is a minus sign, then automatically, you know, when you put a minus sign, the trend reverses. Correct or not? Which is the bigger number, 3 or 5?
5.
Which is the bigger number, 3 or 5?
5.
Which is the bigger number, minus 3 or minus 5?
Minus 3.
Minus
3.
So, clear? So, which point will have more potential energy, P or Q? Ajo. Which point will have more potential energy, P or Q? Q. Why Q? Because it is far. Because it is far. That is when the negative charge is at here, the system has more potential energy. Small minus more, less minus more, negative. Understood? Step the other way. Clear? Suppose this question would be asked directly, then I will not do it by this method. I will do it by this one. Okay, કારણ કે એમાં કોણ potential find કરવા જાય છે તો ફટાફટ. Understood? So that's part B. Any questions? Another way. હજી એક concept. Do you remember that when you allow something to move freely, it always moves such that, can you complete that sentence? When something is to move on its own, it always moves such that. Can you complete that sentence? If you allow something to move on its own, it always moves such that. Total energy is 0. Breaking through?
Potential energy will start increasing.
Yes, it will always move so that potential energy will decrease. Anybody going this potential energy within? It's impossible. Drop the pen. Why does the pen go down? Because if it goes down, potential energy will decrease. If it goes up, potential energy will increase. Is that clear? Yes or no? Sure? So here also you will use that to decide. See, if you have got a negative charge and a positive charge, they attract or repel? Attract or repel? Attract. Okay, so P થી મૂકો તો Q જાય કે Q થી મૂકો તો P જાય? If you put this negative charge at Q, will it come to P? Yes or no? Yes or no? That means at P potential energy will be less. At Q potential energy will be more. See how powerful logic is. આ બધું એમાં આવી ગયું. In that one sentence, that when things move on their own, they try to go towards those positions where the potential energy will decrease or it will be less. Okay? This sentence is gone. Okay, whenever something moves on its own, it tries to decrease potential energy. એના કારણે જ આખી દુનિયા ચાલે છે. I'm being very clear. Right? When? So that's how you can easily decide that potential energy at T is less, potential energy at Q is more. How is it now? Easy to do? Okay, fine. Now, there is one more question about figure A. Okay, we'll talk about that also. After B, now see, give the sign of work done by field. See, work done by field. Symbol WE. We have to find sign of WE in moving a small positive charge from Q to P. Positive charge or negative charge. That means you cannot use anything from P. Did you get it? Okay, do not use any result from P. Okay, again, what are we doing? We are moving a positive charge from Q to P. Clear? Q is initial and P is final. Okay, how do you find WE? Always WE is equal to minus delta U. Delta U नहीं. Good. WE is equal to minus delta U. Clear? So what should I write? Minus Q common VP minus V2. Clear or not clear? Yes, no? Yes. Sure? Yes. Enough of reading. Delta U. What is delta U? Q delta V. Fine. Now let's see the sign. Minus sign is there. Very good. Minus sign has a minus sign. Q has plus or minus? Okay. Question में लिखो जे small positive charge is moved. ये लिखो ना. So Q is plus. Okay. Now what about this bracket? VP minus VQ. What about that bracket? Positive. Positive or negative? Positive. Did you use part A or part B? Part A. Part A. Okay. Positive. Clear or not clear? Yes. Sure. Yes. No. Yes. So finally. Method clear. The work done would be negative. Another method. Have a look here. This is positive. This charge is also positive. Attack or repel? Attack or repel? Repel. Okay, so the force acting on this positive charge will be in this direction. Electric force will act in that direction. Displacement is in which direction? Q to B. So look at that. Displacement is in this direction. And electric force is in this direction. What's the angle between them? 180, or at least it would be obtuse. Is that okay? If the angle is obtuse, the work done by the force is negative. Why would negative? Math program. Only physics. Clear? Was methods clear to you? Yes. I think the second method is really very good. I am going to reach out on for only basic. Right? Force up, displacement down. Work negative. Good. Fine? With that, let's end this class.